This is Mrs. James. We're making our way through our end of course exam review, and this is Astronomy Part III. In our last session we talked about the Big Bang model, and we talked about stars, what they are, and how our star is a very regular old star, and is one of the billions and billions of stars. So let's continue. Let's talk about how stars are classified. We can classify stars by their color, by their size, by their luminosity, that means brightness, and by their mass. Alright, there's a special kind of picture. The picture is called a Hertzsprung-Russell diagram, and I know you might need to pause so you can write that down. This is a chart that can be drawn, and it's used to estimate the sizes of stars and predict how the stars will evolve. Okay? Most of the stars in the universe that we can see follow what's called the main sequence of the Hertzsprung-Russell diagram, and I'll show you what that means in just a minute. And it's a diagonal band on the picture running from the bright hot stars on the upper left to the dim cool stars on the lower right. Now I know that doesn't mean anything until we look at the picture, but we're going to expect some kind of picture, and we're going to see a band that's going to go like this, and we're calling those stars that are on that band the main sequence stars. So let's take a look at that. Alright, here it is. There's the Hertzsprung-Russell diagram. Alright, so it's basically a graph. On the x-axis we're graphing the brightness, which we're calling the luminosity of the stars. And on this part down here, we are graphing the temperature of the stars. And we're doing that according to color. Don't be intimidated by this picture. All this is just a scatter graph. It's just a scatter plot, that's all it is. Each of these each of these stars is just representing a dot like you've made many times before on scatter graphs. Here's our y-axis and our x-axis. And if you didn't know it, really, really, really hot things that are burning are blue, and just plain old hot things that are burning are red. So this is the hottest stars, this is the coldest stars, and this is the colors that we go through. Alright? Now, as you can see, most of the stars in this picture are running along this strip. Here's our strip that goes from the left to the right, and that is called main sequence stars. And each of these words on here, which I'm sure aren't showing up on your picture, and that's okay, each of these pictures is the name of a star. So these are the stars that we can see. We can see lots more stars than this in the night sky. This is just showing a few of them. And there's our sun right there. Look at this, there it is. Okay, just a plain old main sequence star. Nothing special about it except for us. Alright, this is just another Hertzsprung-Russell diagram. It's exactly the same. All I'm doing here is showing you it made by somebody else, so you see that it can look different when someone else makes the same graph. It looks a lot fancier here. It doesn't look so fancy here. We still have the main sequence. We still have the hot to cold, cooler stars. Remember, they're still amazingly hot. It's just not as hot as these are. And up here we have the brightest stars and the least bright. So any stars that are here are very bright and very hot. Any stars that are over here are dim and not so hot. Very bright but cool, and very dim but hot. And there we are right there in the main sequence strip. Here's our supergiants, our giant stars, and our white dwarfs. Here it is again, just showing you the way that somebody else would have made this chart. So this can look really different based on who made it. And one more time, here it is in boring old black and white. Alright, now this one though has a lot more stars, doesn't it? So we've got a lot more stars plotted. We still have our main sequence strip though. 90% of stars are main sequence stars. Alright, a star's mass determines the star's place on the main sequence and how long it will stay there. Remember, we learned last time that the life cycle a star goes through changes a little bit based on its size. We learned how regular stars like the sun go through the cycle. They run out of fuel, they shrink, that makes new nuclear reactions start, they get really big, the cloud of dust and gas gradually floats away, leaving a white dwarf behind. Big stars go through a slightly different version of that and end up as a neutron star, and really big stars go through a kind of a dramatic version of it and end up making a black hole. So, if we look at the star's mass and where it is on the main sequence, as opposed to really big up here, we have some idea of what its life cycle is going to look like. Alright, the Hertzsprung-Russell diagram allows astronomers to see a correlation between the two characteristics of the star, its luminosity and its temperature. And this is a huge correlation for about 90% of the stars. That's why all those stars are on that band that we call the main sequence stars. And only about 10% of the stars that we can see in the night sky are not main sequence stars. So astronomers can do some cool things with that Hertzsprung-Russell diagram. They can use it to, for instance, predict how far away a star is from us. It's also useful just for classifying stars. So astronomers can talk about where a star will be on this chart, and when they do that, they're speaking a common language, so they can discuss stars with this as the background for how they classify them and how they talk about them. Alright, we're almost done with this session, so I want to wrap up just a couple of misconceptions that are very common about waves. One is that the Doppler shift and redshift are different. That's not true. The redshift is an example of the Doppler shift. Alright? It's just that redshift is specifically talking about light, and the Doppler shift, or the Doppler effect, is talking about any kind of the shift that's caused by a moving object emitting waves, whether it's light or sound. So again, redshift is specifically to the Doppler effect that's being caused by a moving star. Lots of students have a misconception about the size of the universe. It has billions of galaxies in it, and each of those galaxies has possibly billions of stars. Some students confuse the galaxy and the universe. Again, the universe is everything. The Milky Way galaxy is just our closest billion or so stars to us. And a lot of students think that the sun is very different from other stars. It's not. The sun is a very normal main sequence star.